Buckle up, universe enthusiasts. A mind-blowing discovery made with the James Webb Space Telescope in summer 2023 has left astronomers scratching their heads. They spotted an enormous black hole called UHZ-1, born just 470 million years after the Big Bang. That's super early, folks. The kicker: this cosmic monster was already a massive tens of millions times heavier than our star, the Sun. Now, according to our current understanding, a black hole needs time to grow this huge by chomping down on nearby galactic material or teaming up with other black holes. But UHZ-1's rapid growth is throwing everything we thought we knew into chaos. But here's where things get seriously wild. UHZ-1 grew so enormous so quickly that it defies explanation using our standard playbook. It's as if this black hole was on the scene way before the Big Bang even happened. Now, you might be thinking, hold up, isn't the Big Bang Theory the undisputed champ of cosmic explanations? Well, yes and no. It's been taking some serious hits from rival theories lately. What's behind these blows to its title? So, you're wondering if our understanding of the universe's origin is about to get totally flipped on its head. Maybe there were multiple Big Bangs or none at all. Or perhaps, these contradictions are just tricks of the light, illusions that make us question everything we thought we knew. Let's go back in time and see why scientists picked the Big Bang Theory as the leading contender in the first place. It all started in the early 20th century when most experts believed space had been chillin' in a super stable, unchanging state since day one. Fast forward to the early days of cosmology, a time when scientists believed in the steady-state universe, think no beginning, no end, and no dramatic changes, just pure stability. One of the biggest advocates for this theory was Fred Hoyle, an astronomer with a sharp mind, teaming up with Austrian physicist Thomas Gold to make it happen. But then came Edwin Hubble's groundbreaking discovery in the 1920s, redshift. It showed that galaxies are actually moving away from each other, and their light is getting stretched out, shifting towards the redder side of the spectrum. Now, you'd think this would have been a major blow to the steady-state model, but surprisingly, its supporters were not entirely shaken off by this new info. Thomas Gold came up with a clever counterattack for the steady-state universe. He suggested new matter could be popping into existence, keeping the overall density just right. It sounded like science fiction, though an endless, infinite universe where galaxies and stars magically materialized out of thin air. Not everyone was buying it, especially Edwin Hubble himself. But little did they know, a Belgian astronomer named Georges Lemaitre had been quietly working on something that would change the game forever. He started with a straightforward question: what if we're not looking at an eternal universe, but one with a beginning? Fast forward a few billion years. If galaxies are spreading out now, they must have been jam-packed together way back when. We're talking so close they wouldn't even be recognizable as separate galaxies. They'd essentially be one gigantic, super-dense particle. Lemaitre dubbed this phenomenon the primeval atom. He proposed that this tiny powerhouse blew its top in a massive explosion and voila, the universe was born. At first glance, this idea might seem like standard-issue science fare today, but trust us, it wasn't always this way. In fact, when Lemaitre first floated his theory, not many took him seriously, dismissing it as more of an astronomy punchline than actual groundbreaking research. Imagine telling scientists back then that our universe began as a singularity and expanded from a single point. They would have laughed it off, thinking it was as ridiculous as a flat Earth resting on 3 giant elephants. That's exactly what happened when Lemaitre first shared his primeval atom concept. To poke fun, another scientist, Fred Hoyle, jokingly nicknamed this idea the Big Bang, basically saying it was crazy talk. Little did he know, history would turn those tables. Today, we're still talking about the Big Bang. And here's a surprising twist: one of its so-called inventors, Fred Hoyle himself, doesn't actually believe in it. Fast forward to 1965, when 2 American physics pioneers, Arno Penzias and Robert Wilson, stumbled upon something truly groundbreaking. They discovered the cosmic microwave background radiation. This faint, persistent glow is like the gentle warmth that lingers after you've blown out a campfire. But here's what's even more mind-blowing. This leftover heat from the universe couldn't be explained by the widely accepted steady-state theory at the time. It was as if their discovery was a smoking gun, pointing to the truth of the Big Bang theory that Hoyle had once ridiculed. The underdog Big Bang theory was now on top, or so it seemed. But the steady-state supporters refused to throw in the towel. In a last-ditch effort, German physicist Fritz Zwicky proposed an idea that sounded almost too good or bad to be true: tired light. According to this hypothesis, the cosmic microwave background radiation wasn't a leftover echo from the Big Bang, but rather regular light that had simply lost energy during its epic journey through space. It was like saying a marathon runner's fatigue was due to the road conditions, not their actual running. It was an attempt to save face for the old theory, and it wouldn't go down without a fight. But wait, Zwicky's tired light hypothesis was about to get a serious challenge. Scientists dug deeper and made some killer observations. They found that no matter what type of light they looked at lie, from the reddest hues to the bluest vibes, it all seemed to lose energy at exactly the same rate. That was weird because, if tired light were real, different types of light should have been zapped at different speeds. It was like a cosmic puzzle piece that didn't fit. Then, as telescopes got way more powerful, astronomers stumbled upon mind-blowing objects called quasars. These are basically supercharged black holes at the centers of galaxies, blasting out an insane amount of energy. But here's the thing, they only spotted these behemoths in far-off, ancient galaxies. If the universe were stuck in a never-ending loop and always looked the same, we'd expect to see quasars lighting up our present-day cosmos too. But nope, this discovery was like finding a cosmic clock ticking away, revealing that the universe is indeed evolving over time. But there's more. Scientists discovered these super-old clouds of hydrogen gas floating around in space. And here's the thing. They couldn't have just been hanging out forever because eventually they would have transformed into stars. It's like they were frozen in time, waiting for us to find them. Then, in 2022, a major breakthrough happened when astronomers discovered an entire galaxy called Nebra, which is literally made up almost entirely of inactive gas. This finding was huge because it showed that the universe has been around long enough for these gases to accumulate and form a galaxy, but not so long that they've all turned into stars yet. Now, you might be wondering how old our universe actually is. Well, it wasn't until 2013 that scientists finally got their answer thanks to the Planck space mission. By studying the leftover heat from the Big Bang, known as the cosmic microwave background, they were able to determine that our universe is approximately a whopping 13,800,000,000 years young. This age discovery was a game-changer because it matched up perfectly with the ages of the oldest stars and galaxies we've found so far. By the end of the 20th century, more and more discoveries kept pointing to the Big Bang Theory as the most accurate explanation for how our universe began. But here's the thing, the more we explored space, the more questions started popping up. One of the biggest mysteries is, what happened to all that antimatter? You see, according to the Big Bang Theory, matter and antimatter should have been created in equal amounts, but it looks like something weird went down, and most of our universe ended up being made out of regular matter instead. So here's the thing. Scientists have been searching high and low, but not a single star or galaxy made out of antimatter has been found. This is super weird because the Big Bang Theory actually said that matter and antimatter should be created in equal amounts. But when we take a closer look at our universe, we see something crazy. The amount of regular matter is 10 billion times greater than scientists predicted. Originally, they thought there'd be around 10 to the power of minus 17 particles per cubic centimeter, but what we actually observe is at least 10 to the power of minus 7 particles per cubic centimeter. That's a massive difference, and it's got quantum physicists scratching their heads. They're thinking that maybe, just maybe, something called baryon asymmetry happened really early on in our universe's history, when matter and antimatter were first emerging from pure energy. This would mean that somehow, for no apparent reason, the universe decided to tip the scales in favor of regular matter over antimatter. Let's break it down. Scientists are thinking that maybe some of that antimatter just naturally decayed away, leaving us with all this regular matter to form our galaxies. But here's another mind-blowing thing. According to the Big Bang Theory, the matter in our universe shouldn't be distributed so evenly across space. Because of how fast light travels, different regions of space couldn't have talked to each other quickly enough to show such a smooth, uniform distribution, especially when it comes to temperature. But here's where things get really cool. If we look at that leftover heat from the Big Bang called the cosmic microwave background, scientists found that it's almost perfectly balanced. The difference between the hottest and coldest spots is only about 18 millionths of a degree on the Kelvin scale. Basically, no matter where you measure, the temperature across our universe is remarkably consistent. It's like the universe had some kind of cosmic thermostat to keep things just right. Here's the deal. According to the Big Bang Theory, it wouldn't make sense that our universe looks so uniform, because different regions couldn't have talked to each other about their temperature fast enough due to that speed of light limit. To fill this cosmic puzzle piece, scientists came up with something called inflation theory. Imagine the universe was like a tiny balloon at first, temperatures could still balance out. But then, bam, a rapid expansion happened in an instant, much faster than light. It's like when you blow up that same balloon and it expands super fast with one quick breath. This inflation theory tries to explain how our universe got its remarkable uniformity, and it's still a mystery waiting for the next big discovery. Inflation theory also claims that our universe grew from an incredibly small point to massive cosmic scales in a blink of an eye. Think seconds, not years. It tries to solve another mind-blowing mystery, why the universe looks flat on big scales, like a smooth crumpled tablecloth. When you stretch it hard enough, all the wrinkles disappear. This theory hooks up nicely with the Big Bang model, and lots of scientists love it. But here's the real puzzler. It doesn't tell us why this inflation happened in the first place. In other words, who or what pulled that cosmic blanket smooth. Astronomers have their work cut out for them figuring out some of the universe's biggest secrets. There's another challenge, the lithium problem, or the lithium discrepancy. If the universe started with a super hot Big Bang explosion, we'd expect it to have created some lithium and way more helium. But when scientists looked at the chemical makeup of old stars, they found that the lithium levels were lower than predicted, like half the expected amount. This cosmic conundrum remains unsolved. No one can explain why this happened. It's as if the Big Bang Theory is a tough champ in a fight, taking punch after punch, but still standing tall with a little help from its scientific cornermen who keep giving it another chance. The tired light hypothesis thought it would land a knockout blow to our champ, the Big Bang Theory. Physicist Rajendra Gupta stepped into the ring with new data from the James Webb Space Telescope in 2023 and proposed a fresh twist that physical constants might change over time and space. He suggested that the universe could be older than we thought, even up to 26,700,000,000 years, by reimagining tired light through the lens of quantum physics. But the scientific community is staying cautious, hesitant to rewrite the Big Bang model's rules just yet. History has shown us, though, that what was once considered extreme can become mainstream. Who knows which theory now seen as radical might one day dethrone our reigning champ? Buckle up, we've got a game-changing theory on the table. Physicists Paul Steinhardt and Neil Turok threw down the gauntlet back in 2002 with their cyclic universe model, suggesting that our Big Bang wasn't such an isolated event after all. Their idea proposes that space goes through cycles of expansion and contraction. Each Big Bang is followed by a massive collapse known as the Big Big Explosion. All matter and energy are squished into a tiny point of extreme density and heat, only to burst out once more and kickstart a fresh cycle. This theory helps make sense of some mind-bending cosmic observations that have left traditional Big Bang thinking scratching its head, like those weird fluctuations in the cosmic microwave background or the surprisingly uniform matter distribution. Could this cyclical model be the one to finally knock our champ off its pedestal? You might have guessed it. Our cyclic universe theory has some pretty cool implications. The idea is that these features we see today, like those wacky fluctuations, could actually be leftovers from the previous cycles. But here's the catch: in this bouncing cosmos, entropy starts to build up over time. Think of it like a worn-out basketball. With each bounce, its height gets lower and lower. Now, Roger Penrose, a total legend in the physics world, came along and said, "Hold up, I think I've found something." He's been looking at those cosmic microwave background patterns and thinks he spotted some circular signs that could be radiation from black holes' war. Yes, you read that right, Balashke Holes from a previous cycle. This is known as conformal cyclic cosmology, and it might just be the key to understanding our universe's crazy history. Let's dive back into this mind-blowing cosmic history. Roger Penrose's conformal cyclic cosmology is all about black holes playing a major role in our universe's story. According to him, as each cycle ends, these massive black holes would completely evaporate, taking entropy with them and giving the new cycle a clean slate. That's like hitting the reset button on the universe. Now, you might be wondering how this stacks up against other theories. Well, even though it's still not as widely accepted as the Big Bang model, cyclic cosmology is definitely in the running as one of the strongest alternative ideas out there. Penrose actually came up with his theory to challenge another big-name concept called eternal inflation, which was introduced by physicist Andrew Lindy back in the 1980s. The original inflationary model had a problem. It needed really specific conditions to work across the entire universe, kind of like needing the perfect amount of air for a rocket to blast off. Get ready for some major cosmic mind bending. Andrew Lindy's eternal inflation theory shook things up when he proposed that inflation didn't just happen once. It's been happening everywhere all the time. According to him, random quantum fluctuations kept triggering new rounds of inflation, creating an endless sea of universes, or what we call the multiverse. It sounds like something straight out of a Marvel comic, but trust us, this is real science. The catch: these other universes are totally invisible to us, making it impossible to prove they exist. So, while eternal inflation is one wild ride, the Big Bang model still reigns supreme thanks to its massive pile of supporting evidence. For now, that's what wins in the battle of the theories. Let's dive into some seriously cool cosmic concepts. In the 90s, physicists Edward Witten and Juan Maldacena, not Witten, joined forces to develop a mind-blowing idea called brain-world theory, part of the string theory universe. Imagine our reality as just a three-dimensional brain or membrane floating inside a massive, higher-dimensional space. These brains can actually interact with each other when they collide, and scientists believe that these crashes could be the spark that creates brand new universes, similar to how we think the Big Bang formed ours. This is some seriously out-of-this-world stuff, folks. So, here's where things get interesting. Despite all this mind-bending potential, brain-world theory still hasn't been able to deliver on its promise of extra dimensions, and scientists haven't found any proof of these higher dimensions in our universe. So, for now, the Big Bang remains the star of the show. But what's really wild is that some scientists are so dedicated to exploring alternative theories that they're taking things to a whole new level. Literally. They're questioning whether gravity even exists as we know it. Crazy, right? Hold on to your seat because things just got electric. You might be surprised to learn that right now. What's keeping you grounded is actually a type of invisible force called the electromagnetic force, not gravity at all. David Talbot and Wallace Thornhill took this idea to another level with their book in 2007, introducing a totally unconventional theory known as the electric universe. According to them, it's not gravity that powers most space phenomena, but electromagnetic interactions that light up our cosmos. So, what if stars and planets aren't actually formed by gravitational forces, like we've been taught? Get ready to spark your curiosity. In the electric universe theory, it's not just gravity that's calling the cosmic shots. Electric currents and fiery plasma interactions are fueling a web of electromagnetic fields that wrap around every galaxy and star system out there. This electrifying force is what keeps planets in their orbits and guides celestial bodies through space. Unlike the Big Bang, this model doesn't believe in an expansion of space from one singular point. Instead, it imagines a universe constantly changing with no beginning or end. Think of it as a cosmic dance with no starting beat. While some parts of plasma physics, like what Talbot and Thornhill propose, have been tested and proven in lab experiments and even right on our star, the Sun, there's still much to explore within this bold electric universe vision. Now let's put on our critical thinking caps. You might have heard that gravitational waves from colliding black holes have been detected, a major win for Einstein's gravity model. But some electric universe fans are saying those ripples could actually be signs of electrical events. However, we're not magnetically attached to the Earth, so it seems even their own bodies contradict this idea. Moving on, all recent astronomical observations support the gravitational theory. But here's where things get really interesting. A major problem scientists can't shake off in both the Big Bang and gravity models is the concept of a singularity and infinitely dense point that supposedly existed at the universe's birth and inside black holes. This mind-bending idea still leaves many questions unanswered, making it a cosmic puzzle waiting to be solved. Get ready for a totally mind-blowing concept. Physicist Robert Hastings dared to challenge the status quo by proposing a bold idea. What if the singularity at the heart of our black holes and the one thought to have triggered the Big Bang are actually one and the same? This theory, known as the black hole universe model, turns everything we think we know on its head. According to it, the density of our observable universe could be equivalent to that of an enormous black hole, and there's a boundary, like an event horizon, beyond which lies the unknown. Hastings' radical suggestion is that our universe didn't begin with the Big Bang explosion after all. Instead, it might have started as a supernova in a previous universe, expanding outward ever since. The black hole universe model takes a wild turn. It suggests our cosmos could be the result of a supernova in another universe, which then collapsed into an enormous black hole. No singularity needed here. This theory proposes that universes could potentially give birth to new ones, forming a cosmic Russian nesting doll effect. But hold on to your seat, because proving this idea is basically impossible due to our limited peaking abilities. Hastings presented it as a way to expose the gaps in modern physics. And if you're still reeling from the multiverse concept, get ready for the next mind blow, the holographic universe theory. Physicists Gerard Hooft and Leonard Susskind shook things up while tackling the black hole information paradox. They proposed that our entire universe could be a hologram. Yes, you read that right. Here's the rewritten paragraph. Now let's dive into the holographic universe theory, a real brain twister. Think about a black hole. Its surface, called the event horizon, seems like an impenetrable wall. But quantum physics insists that all the information about what's inside is somehow saved. Gerard Hooft and Leonard Susskind came up with a mind-bending solution. They suggested this info isn't trapped inside. Instead, it's actually encoded on the black hole's surface. If we take this idea to its limit, an entire universe could be hiding within a black hole, with everything projected onto its boundary. That means our own universe might just be a hologram, a three-dimensional illusion created from a hidden layer of reality. This level contains the fundamental properties that shape our cosmos. Maybe it even predates the Big Bang. However, to confirm this theory, we'd need to break free from our reality's boundaries and look beyond, something that's sadly impossible for us. Here's the rewritten paragraph. But then, a philosopher named Nick Bostrom stepped in with his simulation theory, a bold idea that suggests everything we experience is actually an artificial reality created by super advanced beings. Imagine it, our universe, a vast video game full of glitches and inconsistencies. The Big Bang Theory's problems might just be cosmic bugs waiting to be patched. But for me, the simulation theory feels like a shortcut around the real mystery. Let's face it, despite its flaws, the Big Bang remains our best explanation for the universe's origins. And even when new discoveries lead to a better theory, that's science doing what it does best, evolving and improving. No need to worry. We're on this wild journey of discovery.